Compute delta y and dy for the given values of x and dx equals delta x. Sketch a diagram to show dx dy delta y. So first we'll start with delta y. Delta y is f of x plus delta x minus f of x. So x in this case is 3. We're told that delta x is 0.5. And f of x again we said is 3. So now we have f of 3.5 minus f of 3. F of 3.5, again plugging 3.5 into the f function, we get negative 1.75, and plugging in 3 we get negative 3. Negative 1.75 plus 3 is 1.25. So that is delta y. Dy is f prime of x times dx. F prime is 2x minus 4. Dx, we are told, is 0.5 because delta x and dx are the same. So here we can also plug in 3 for the x value. Simplifying this, we get that dy is 1. Now we want to sketch a graph to show dx, dy, and delta y. Up next, we'll plug this into the calculator. Go to y equals and type in x squared minus 4x and graph it. So we get this parabola. If we want to, we can zoom in a little bit. I'm going to use zoom box, zoom number 1. Move your cursor so that it is in one of the corners of the window that you want to draw. I'm going to do it roughly right there, hit enter, and then we can draw the rest of the box, making sure that the important parts are in the window. X-intercepts are nice to be able to see. It's nice to be able to see the x and y axis. And we also want to make sure that x equals 3 is in our viewing window. Hit enter, and that'll zoom into that specific region. And now we can create a rough sketch of what we have. So we're going from 0 to 1, 2, 3, 4 on the x-axis, and it looks like roughly 4 on the y-axis, negative 4. It looks like the vertex is around 2, 4. We can double check that either using algebra or we can quickly do it using second calc number 3. Do our left and our right bounds just to make sure that that is at 2, negative 4. Some rounding errors there, but it is 2, negative 4. And we can see that we have an x-axis, an x-intercept at 0, and an x-intercept at 4. From here we'll just do a rough sketch of this graph. And we're focusing on when x is 3. So that's happening here, roughly right here on the quadratic. That's when x is 3. Delta x is 0.5, so roughly this amount. Delta x and dx are the same. The tangent line at that point we can approximate. It looks something like this. Note that we found dy to be 1. dy is this distance. It's how much the curve rises or falls.